Once again, welcome students. In this unit, we are discussing various advanced plastic processing techniques. In our early modules, we had discussed the basic principles, process and applications of thermoset injection molding, gas assisted injection molding, thin wall injection molding, and co-injection molding. Now in this module, we will be discussing the basic principle, process and applications of liquid injection molding. So what is liquid injection molding? In liquid injection molding, normally silicon rubber is mainly used. So it is also called as liquid silicon rubber injection molding. Liquid silicon rubber injection molding is a thermoset process that cools the material delivery system. That is, in barrel, the material will be in cold condition and the mold will be in hot condition. So the material from the barrel is injected. It's the same thermoplastic like injection molding process only, but here the barrel is in cold condition and the mold will be in hot condition. So the material is injected into the mold and it cures in the mold and the final product is obtained. So liquid silicon rubber injection molder parts are elastic with a high degree of chemical, electrical and thermal resistance. In addition, the liquid rubber injection molding parts are biocompatible. So in medical applications, they find lot of applications, and they withstand very high temperature, so they can be subjected to sterilization also. Now we'll see the processing technique of liquid injection molding. The liquid silicon rubber injection molding machine appears to be just like, as I said, it looks just like the thermoplastic injection molding machines. Both types of presses uses the same basic machine parts, clamp unit and injection unit in thermoplastic, also in liquid rubber injection. Every parts will be the same. The silicon injection molding machine typically have a hydraulic ram and may have hydraulic toggle clampings. Some presses are designed with electric ram and electric toggle clamping also. Unlike high pressure used to mold thermoplastic parts, liquid injection molding pressure is in the range of only 800 psi. The purpose of clamp is to contain the expansion force of the silicon material by keeping the mold closed as the rubber cure in the mold. The same like here the material will be fed here, and in the hopper it is fed, and through screw the material gets plasticized and material accumulates here. Once the required amount of material is accumulate in front of the screw, then it is injected through this screw, and it gets filled in the mold where it gets cured. Since the mold is at higher temperature, it gets cured, and after curing the part is removed from the mold. The injection unit of liquid silicon runs cool with a water cooled barrel and nozzle to prevent the liquid before going into the mold. The material should not be cured. So we have to cool the jacket. The jacket of the barrel should be cooled, maybe water cooled, so that once it enters into the mold only, it has to get cured. Whereas for a thermoplastic injection unit, it runs in the opposite way. That is, they need need the barrel to be heated. Maybe it depends on the type of plastic we are using, from 200 degrees centigrade or more than 200 degrees centigrade. Then after processing, it is injected, and it gets the product will be formed in the mold, where the mold is cooled for thermoplastic. But for liquid injection molding, the material should be heated in the mold. And the liquid injection molding units also run at low pressure, less than 1000 psi, whereas in thermoplastic injection molding, tens of thousands of psi is required. And there is a part A. We contain a part A and part B. Colorants, if required, they come in the form of dispersion and are normally 1 to 3% weight of the mixed silicon. And the silicon dowsing units pumps one part of A silicon and one part of B silicon via separate hoses to the static stirrer. This is the stirrer where this part A and part B get mixed in the static stirrer. And also the color is pumped to the static mixer. So after mixing these three units, the mixed components are then feed into the throat of the injection molding barrel by the way of shuttle of valve. The liquid injection molding machine includes, so we have different parts, that is injectors. This device pressurizes the liquid material, and metering units. So in order for liquid injection molding to be successful, there needs to be a catalyst and the base forming silicon material. Metering units help ensure that these two materials maintain a constant ratio while they are in process of being released. And we have supply drums, and we have mixers. The static mixer, as we seen in the earlier slide, this is the static mixer, and these three components and a nozzle, they carry out the injection into the mold. Then finally the mold and its clamp. This were the secure mold during the production process, as well as when the mold opens and the product is, and the process is completed, and we get the product. Once the silicon material is inside the barrel, the shot of the cool mixed silicon rubber advances the mold as the nozzle seals firmly against the mold. And the nozzle shut-off valve opens, and a measured shot of liquid silicon rubber is injected into the hot mold, usually 275 degree Fahrenheit to 390 degree Fahrenheit. Then the nozzle shut-off valve open, and the barrel retracts from the mold, while the screw being built another measure of for next cycle, and the cold silicon rubber is accumulated. After silicon vulcanizes in the mold, heated mold, the clamp will open, and the parts are then manually removed or automatically ejected. And the cycle time for silicon rubber molded parts are often similar to that of its thermoplastic counterparts. Now we shall see what are the advantages of liquid silicon rubber injection molding. The liquid silicon rubber based products have constant mechanical properties over a wide temperature range, and there is a labor intensive preparation of rubber based product is eliminated. Since here it is automatically mixed, we need not to prepare the rubber based products like in conventional rubber manufacturing process. In liquid silicon rubber manufacturing, this labor work manual is reduced, and we have shorter cycle time and shorter injection pressure also. This liquid silicon rubber products, they have excellent ozone resistance, UV resistance, weather resistance, and also they possess excellent chemical resistance. So owing to these advantages, they find lot of applications. The typical application includes seals of all kinds, various seals, O-rings, isolators, electronic components, and parts in aerospace and automotive industries, and many electrical devices, and numerous medical parts are being manufactured by using liquid silicon rubber injection molding techniques. So we have seen in this model the basic principle behind the liquid injection molding, their processing characteristics, their merits and demerits, finally the applications of liquid silicon rubber injection molding. In our next module, we will be discussing one more interesting advanced plastic processing technique that we will discuss in the next module. Thank you.